Hello students, this is Kashima Soni and today we are going to start a new topic, that is crystal field theory. So let's take up our topic. Crystal field theory. Before jumping to that, let's talk about coordination compounds. See, coordination compounds have very interesting geometry that we have seen so far, and many of these cannot be explained by same models that we use for normal covalent compounds like your VBT and Vesper. They are usually not going to explain all of the interesting geometries of coordination compounds. So what will happen over here, we'll talk another kind of interesting concept over here, that is your CFT, crystal field theory. And what will happen over here, let's discuss that in detail. First of all, who has given your CFT? It has been developed by H. Beat and V. Blake. The name of the scientists were H. Beat and V. Blake, and the theory is entirely different as compared to that of your VBT. What VBT says that the interaction between your metal and ligand is going to be covalent, correct? But this is not going to explain all the geometries of your coordination compound. So there comes your CFT, which states that the interaction between your metal and ligand is going to be purely ionic, or you can use another term, that is electrostatic, correct? So that is one thing over here. Now see what will happen next is your metal and your ligands, they both are going to act as point charges, correct? What they are going to act, they are going to act as a point charges. So the basic and the main assumption of this theory is that the metal ion and the ligands, they are going to act as point charges, and the interaction which is happening in between the metal and ligand is purely electrostatic, or you can mention purely ionic. Okay, that is one thing. Now see what kind of interaction we are going to see in between your ligand and metal. See, if the ligand is negative, what kind of ligand? Negative, like chloride, bromide and cyanide ion. What will happen? The interaction between such kind of ligand and metal ion will result in your ion-ion interaction. Okay, and if we are going to use your neutral ligands like ammonia, water, carbon monoxide, the resulting interaction is going to be ion dipole interaction. So these are the two interaction that we are going to see particularly over here. Okay, now just switch to the another part of your CFT. See, the central idea of this theory is that the metal ion, that is any metal ion in the surrounding environment of your ligand, it is going to create a non-spherical electric field, correct? Which is responsible for the splitting of your orbitals. What will happen? The spatial arrangement of these point charges, if you want to write, you can write down, or I can write it for you. Here you can write down the arrangement, spatial arrangement of these point charges. Which point charges? Your metal and ligand. These point charges, that it will affect the d orbitals of metal atom, and what will happen when they'll affect the or d orbitals of metal atom? It will disturb its degeneracy, and what will happen, it's some of the orbitals energy will raise and some of its orbital energy will be decreased. That we'll discuss later after. For now you can just understand this much. Okay, so the central idea, as I suggested to you, as I have mentioned earlier, that it is going to create a non-spherical electric field, and this electric field is known as crystalline field earlier, but now we call it as crystal field, and the theory hence named as crystal field theory. That is one thing. Now let's just switch to the postulates. See, the transition metal ion surrounded by the ligand with a lone pair of electron. What they are trying to say, जो आपका metal है, particularly transition metal having d orbitals 3d, 4d, 5d, it could be any. Basically your transition metal it should be. Okay, so it is surrounded by ligands. जो भी ligand इसे surround कर रहे हैं, it should have lone pair of electron available for donation to the metal. Okay, and all type of ligands, and they are going to be regarded as point charges like this. They are going to be regarded as point charges, not just ligands. Your metal as well is going to be regarded as the point charge. Okay, so the ligand that I have already told you, that we are going to see negative ligand, which is going to result in your ion interaction, and your neutral ligand, which is going to result in your ion dipole interaction that we have already discussed in first slide. This is no need to explain it again. So let's just see. Okay, this is your ammonia molecule, and you can see the dipoles creating over here. You can see N is being more electronegative in nature will be carrying partial negative charge, and your hydrogen being electropositive will carrying a partial positive charge. Okay, so that is also one thing. This is the sort of showing your ion dipole interaction, which is due to your neutral molecule ammonia NH3, and also it is due to your another neutral molecule, that is water. You can see dipole has been created, you can see clearly. So let's just switch to the postulates portion of your CFT. Let's just continue discussing the same. Okay. So the interaction between your metal ion and negative end of ion, it is purely electrostatic. Yeah, it is C over here, electrostatic. So the bond is considered 100% ionic. That is the main assumption of your CFT. You need not to forget that. It is very important to remember whenever you are going to compare your VBT with CFT. You should remember over there in VBT the interaction is covalent, and over here it is purely ionic. Okay. Now another point is the ligand surrounding the metal ion produces electric field, influences the energies of the orbital of central metal ion, particularly the orbitals. So I told you earlier only that your ligands are going to create your non-spherical electric field, जिसे आप crystal field कहते हैं, और उस स्पेशल अरेंजमेंट की वजह से क्या होगा, इन पॉइंट चार्जेस की वजह से जो आपकी डी ऑर्बिटल्स है उनकी एनर्जीज पे इफेक्ट पड़ेगा, डीजनरेसी डिस्टर्ब होगी, and some of the d orbitals will rise in energy, some of them will decrease in energy. That we'll discuss further later after. Okay. And another point is in case of free metal ion, all the 5d orbitals have same energy. अगर आपके पास free metal ion है, वहाँ पे कोई non spherical electric field नहीं है, उस केस में आपके 5 orbitals जो होंगे they are going to have same energy. Such orbitals which have same energy, they are called degenerate orbitals. This means that an electron can occupy, मतलब एक इलेक्ट्रॉन किसी भी आपके ऑर्बिटल्स में जा सकता है, dxy, dyz, dxz, dx स्क्वायर माइनस वाई स्क्वायर और dz स्क्वायर. इनमें से 5 में से किसी भी ऑर्बिटल में आपका इलेक्ट्रॉन जा सकता है. दैट इज वन थिंग ओवर हियर. Due to repulsive force between your central metal ion and ligand, the electron on the metal occupy the d orbital as far as possible. अब क्या हो रहा है कि आपका जो मेटल है उसमें जो एग्जिस्टिंग आपकी इलेक्ट्रॉन डेंसिटी होगी वो आपके लिगेंड जब अप्रोच करेंगे, उसकी लोन पेयर ऑफ इलेक्ट्रॉन जब आपके मेटल को अप्रोच करने की कोशिश करेंगे तो क्या होगा, जो ऑलरेडी प्रेजेंट इसकी इलेक्ट्रॉन डेंसिटी है इट विल ट्राई टू रिपेल, वो रिपल्शन क्रिएट करने की कोशिश करेगी. ठीक है, रिपल्शन की वजह से क्या होगा, जो आपके इलेक्ट्रॉन है मेटल आयन में वो दे विल ट्राई टू रिमेन एज फार एज पॉसिबल फ्रॉम द डायरेक्शन ऑफ अप्रोच ऑफ लिगेंड. ओके, दैट इज वन थिंग. और अगर ये जो रिपल्शन हो रही है इसकी वजह से क्या होगा, दिस विल रिजल्ट इन द एनर्जी इन द हायर इन रेजिंग द एनर्जी ऑफ योर डी ऑर्बिटल. इस रिपल्शन की वजह से आपकी जो एनर्जी है डी ऑर्बिटल्स की वो इंक्रीज हो जाएगी, विच मीन्स कि अगर एनर्जी इंक्रीज हो जाएगी तो आपकी स्टेबिलिटी उन पर्टिकुलर डी ऑर्बिटल्स की जिनकी एनर्जी इंक्रीज हो रही है उनकी स्टेबिलिटी डिक्रीज हो जाएगी. ओके, दैट इज अनदर थिंग. Continuing with the postulates, so these are some of the important points to discuss. See, if the ligands approaching the central metal ion is at the same distance from each of the d orbital, the energy of each orbital will increase by same amount. What they mean कि अगर जैसे आप अपना ऑक्टाहेड्रल का ही एग्जांपल ले लीजिए, कि कहने का मतलब क्या है कि अगर आपके अप्रोचिंग सेंट्रल मेटल आयन जो है जो लिगेंड के से इक्वल डिस्टेंस पे है, तो आपके जो 5 डी ऑर्बिटल हैं उनकी एनर्जी इंक्रीज करेगी सेम अमाउंट से. ओके, ऐसा नहीं है कि आपके हाफ ऑफ द ऑर्बिटल्स आर इंक्रीजिंग, थोड़ा सा ज्यादा इंक्रीज कर रहे हैं बाकी के 2 ऑर्बिटल से. तो इस केस में आपके जो बाकी 5 के 5 डी ऑर्बिटल्स होंगे दे आर इंक्रीजिंग इन सेम अमाउंट. करेक्ट. अनदर पॉइंट इज the orbitals lying in the direction of ligands will experience greater repulsions and their energies will be raised to greater extent. See, यहाँ पे आपका मेन कंसेप्ट आएगा ऑक्टाहेड्रल वाला जो हम आगे पढ़ेंगे in your next video. क्या होगा, मान लीजिए कि ये है आपका this is your x axis, this is your y axis, this is your z axis. So जो approaching ligands है, you can see if this is your dz square orbital, So, or if these are your dx square minus y square orbital, you can see this is something messed up, but you will see it in our next video. That will be better understandable. So what I'm trying to say that क्या होगा यहाँ पे कि अगर आपके जो ऑर्बिटल्स हैं, मेटल के ऑर्बिटल्स हैं, दे आर लाइंग इन द डायरेक्शन ऑफ लिगेंड, ठीक है, लिगेंड्स की डायरेक्शन में ही वो लाई कर रहे हैं, तो इस केस में आपके पास रिपल्शन ज्यादा होगी मेटल के ऑलरेडी एग्जिस्टिंग इलेक्ट्रॉन डेंसिटी का विद योर लिगेंड, अप्रोचिंग लिगेंड के साथ उसकी रिपल्शन ज्यादा होगी, एंड जितनी ज्यादा रिपल्शन होगी उतनी ही ज्यादा एनर्जी उन पर्टिकुलर ऑर्बिटल्स की इंक्रीज हो जाएगी, ठीक है। तो अगर यहाँ मैंने बात की है डी एक्स स्क्र माइनस वाई स्क्र और डी जेड स्क्र की, क्योंकि वो आपके लिगेंड्स के डायरेक्शन में ही अप्रोच कर रहे हैं, तो क्या मतलब लाई कर रहे हैं, तो क्या होगा, इन दोनों की एनर्जी इंक्रीज कर जाएगी, करेक्ट। सो अनदर पॉइंट इज द ऑर्बिटल, अगर आपके ऑर्बिटल दूर हैं फ्रॉम द अप्रोच ऑफ लिगेंड, तो क्या होगी, लेसर इंटरेक्शन होगी एंड योर एनर्जी विल बी रेज टू लोअर एक्सटेंड, और सच केस में ऐसे जो ऑर्बिटल होंगे उन केसेस में क्या होगा, आपकी स्टेबिलिटी उन ऑर्बिटल्स की जिनकी लेसर इंटरेक्शन है लिगेंड के साथ, उनकी स्टेबिलिटी इंक्रीज होगी, और इस केस में स्टेबिलिटी डिक्रीज होगी, करेक्ट। So okay, so therefore due to the electric field of the ligand, the energy of the orbital will split up, क्या होगा, इसी इलेक्ट्रिक फील्ड की वजह से आपकी जो एनर्जी है डी ऑर्बिटल की, इट विल स्प्लिट अप एंड डिफरेंट एनर्जीज इन द प्रेजेंस ऑफ इलेक्ट्रिकल फील्ड इज नोन एज crystal field splitting, okay। So continuing with few left out postulates, that is the number of ligands and their arrangement around the central metal line will have different effect on the relative energies of 5d orbital। कहने का मतलब क्या है कि अगर हम कोऑर्डिनेशन नंबर 6 की बात कर लें, यानी कि ऑक्टाहेड्रल कॉम्प्लेक्सेस की बात कर लें, तो उनका इफेक्ट जो होगा स्प्लिटिंग पे वो डिफरेंट होगा एज कम्पेयर टू दैट ऑफ योर कोऑर्डिनेशन नंबर 4 हैविंग टेट्राहेड्रल ज्योमेट्री, ठीक है। ये ही इसका मतलब है कि आपकी स्प्लिटिंग वेरी करेगी इन दोनों केसेस में, having different coordination number, it's not about इन दो केसेस में, आपके बाकी भी जो another coordination numbers होते हैं like 5 6 7 8, particularly we are going to discuss 6 and 4 only, so उन केसेस में आपकी splitting वेरी करती है, that is what they are trying to say। So the magnetic properties, spectra, preference for particular geometry, it can be explained in terms of splitting of d orbitals in crystal fields, ठीक है। So that is your another thing, okay। Yeah, so where we are now, we will just be seeing the shapes of d orbital, and that's all about this particular video. See, you can see over here your dYz, dxz and dxy. These all orbitals are going to lie in between the planes. You can see dYz, yz जो है आपका वो y और z एक्सिस के बीच में लाई कर रहा है, यू कैन सी, ओके। सेम इज द केस विद dxz एंड dxy, लेकिन जो आपके dx स्क्वायर माइनस y स्क्वायर है, इट इज गोइंग टू लाई ऑन द particular axis. For example, it is lying in the x axis, you can see over here, and above the y, not above, it is lying on your axis, x and y axis, you can see like that. And this one dz square, it is lying on your x, orbitals are lying on your z axis, that is one thing. So uh, clear these shapes of d orbital, this is going to be handy in your next slide. So that is all about this particular slide. Thank you.